what is the best item in No F3 speedrunning? So, in my opinion, the best item in No F3 speedrunning is an item that lets you measure faster and more efficiently. The measure split, the blind split in a No F3 instance would be the most RNG instance because you are kind of just guesstimating. The look at the side of an eye and jump 4 blocks and go off of that angle. It's like good, but it's it doesn't get you a very, very good angle. It gets you like a estimate, but it doesn't get you a good estimate. So last video, we discussed a way of knowing what angle you're facing in order to do axis travel using the side of a block, right? Each block has 16 pixels. So if we look at this side of a block, we know that we're always facing some angle because the angle never changes no matter what. As long as you're lined up correctly, it'll be the same angle. Except there's an issue with most blocks. And I say most for a reason. This block, right, has 16 pixels on it. So this left pixel, 1.1, to the right of that pixel, 2.1. So there's a whole 1 degree in this pixel. So let's say we were to end up like looking right here at like this angle. How do you know what degree you're facing? It's kind of just a guess. I'm like halfway into it, a little biased to the right. So maybe I'm like 0.7. Okay, I was right. Bang, I'm so smart. But you can imagine that's not very precise. It's not going to get you the best measurement possible. So how can we make the pixels on a side of the block smaller? Well, things, breaking news, as they get further away from you, they get smaller. So if we were to look at the side of this block, now the side of this pixel, 0, the other side, 0.4. So we've reduced the amount of pixels in between, the amount of like degrees in between pixels from 1 to 0.4. But there's kind of an issue with this approach. And it's not an issue with the approach itself. This approach works just fine. But it's an issue with the speedrun aspect. So let's say I throw an eye. I'm looking up to measure it at about 32 to 33 degrees. And what that means is if we wanted to go far away and build a tower to look at, you have to go pretty far to guarantee that you're looking at the correct block. And then another issue is that when you're looking at this, not only do we need to know how many pixels we need to know what block we're looking at. So we would need to count out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 blocks, and then a bit to the side. So we would need to do that for the 10th block out, and we need to count all that way. I don't really like that. It feels tedious, it feels unintuitive, and it feels unnecessary because there exists a way to compact pixels in the side of a block. So what is the best item in No F3 speedrunning? Something that reduces our blind split. Something that reduces our blind split is something with more than 16 pixels. Something with more than 16 pixels is a sign. A sign actually has 24 pixels on it. And if you were to write letters on it, the sign has 91. I'm counting 91 here as it's not actually 91 pixels, but it's 91 unique measurements you can take off of this sign, right? You can measure off the side of each visible change in the sign, right? So there's 91 measurements you can do here. You can write 15 letters on a sign. You can write, there's spaces in between of those. 15 letters, 5 pixels each, 1 pixel space, 6 times 15 minus 1 because there's no space at the end, plus 2 for these pixels at the edge, gets us 91 pixels. So this has 91 measurements. We've taken our original 16 and we've brought it all the way up to 91. So if we were to go ahead and measure this sign, we can see here that we're going from 40.3 to 40.4. That's basically a perfect change, right? We're changing 0.1 degree for each pixel we move. That is basically perfect. So I'm just going to spin around. Okay, we're facing here. So I'm going to measure this angle. Oops. I'm going to measure this angle that I'm facing right now. So I'm looking at a sine. We're looking 3 distance. It is the second block from the diagonal to the right. I'm looking at the 11th letter. I'm looking at the second pixel on this letter. So I think I'm facing 60.6 degrees. Bang. If I were to copy my angle, I'm accurate to 0.03 degrees. We've increased our accuracy from 1 degree. 1 pixel equals 1 degree to 1 pixel equals 0.3 degrees. That's not at all true. We've decreased it from 1 pixel to 0.1 pixel, and that's let us get within 0.03 pixels, 0.3. Oh my God, I'm not re-recording this. This is just one take. We've taken our initial degree change from pixel from a 1 degree change to a 0.1 degree change, which lets us get within 0.03 degrees accuracy. So that's really, really good. That's really, really, really good. But I am personally not satisfied. I want more accuracy than just this. You might have seen it on here, a little bit of a spoiler. ASCII characters. ASCII characters. Minecraft lets you type ASCII characters. So if you didn't know, an ASCII character is if you press Alt and then your numpad, you get ASCII characters. And they can range. There's a lot of these, right? And they can get a lot more precise than these just letters. As far as I know, they can get twice as precise. If I were to do Alt 15 and compare that to just an X, sorry, X is my wide macro, you can see that they're twice as precise, right? This pixel here on the X takes up 2 of these little pixels on the star. So stars are the future. Minor thing, you might be thinking to yourself, you're just placing down these signs with information already on them. You can't really do that on a speedrun because you don't have that NBT data. What you can do, though, is have it in your copy. So if I were to type out, I think it is 18 stars. Copy that. Paste it in. So this is the way you would do it on a speedrun. You would start with this in your clipboard, and then you would get measuring, and then you would face your direction, and you would place down a sign, and you go Control V, enter, Control V, Control V, Control V, and that is how you would do it. So these ASCII characters take our 91 measurements on this normal sign to 178 measurements. Now, I don't know about you, that's a lot of measurements. That is, in fact, more than 11 times our initial measurement. A normal block has 16 pixels, so 16 measurements. We've taken that to 178, which is more than 11 times the amount. So in this short span, we've gained 11x accuracy. But that accuracy comes with a technically minor from your point of view, but major from my point of view. Every time that you get more precise, you have to know what angle you're facing with more things. So if we were to measure here on these 6 signs, then that would be 178 times 6 signs, which is a little over 1,000, like 1,050 measurements that you would have to do in order to know all possible permutations. And there's not like an algorithm you can write for this. They don't increase linearly, or like even exponentially. They'll decrease by like, oh, this one's 0.5, and then the next one's 0.4, and then the next one's 0.8. It's not like a good angle change. So you have to go in and measure each one individually. So if you notice, I forget what exactly the IGT was in my last video, but I'll tell you it was substantially less than 19 hours. And basically, all I did those 19 hours in those hours was F3C, 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 go over F3C, F3C. So I'm kind of fed up, and I didn't want to do a full 3-block copy for this star pattern, because that would be 1,400 Control C's, or F3Cs. And that's a lot of work. I don't have that much time right now. I have finals this week. I should have been studying for those anyway, but it's chill. So I did not do these 3 blocks away measurements. I did these 2 blocks away measurements because that is 2 less signs that I have to Control C, Control V. So I went through and I did all of that for all of those signs. So if I am standing right here and I spin around, okay, I want to measure this angle. So let's line ourselves up. It goes 2 blocks away. So right here, let's place down this sign and zoom in on it. So we are looking at 2 blocks away from us. It is the first block to the right of the diagonal. We're looking at the 5. Sorry, I need to count. 5, 10, 15. This is the 16th pixel, or sorry, 16th letter. We're looking at the 2nd pixel, and we're all the way through it. So sub 1. So I think that we're facing, I think this is neg. I think we're facing 142 degrees. I don't think this is accurate for neg. I think that we're 7.03 off the diagonal. So let's see where we are. 142. Let's F3C to see where exactly we're facing. We're facing 0.03. So we're facing 142.03, which is literally exactly what we measured. We were accurate, not to the degree, not to the 10th of a degree, but to the 100th of a degree. That not just lets us do axis calculated, that lets us do high-res axis calculated. That'll let you know how far you need to go within 100 blocks, even at worst. So this technique is very, very powerful. It's a very, very powerful way to know what angle you're facing. I'm going to, I'll walk you through a axis calculated using this measurement system. I won't go fully into depth because I still have to improve it. I still have to do these signs and Control C, Control V, all of those angle measurements. But I'll walk you through a 2-distance ASCII setup, 2-distance ASCII setup axis calculated. And then in my next video, I will go through a full tutorial on how this Google Sheet I set up works and what a specific measurement means, what everything means basically. So I'm just gonna TP to some random coordinates. These are not, I shouldn't TP like outside of every single ring. These are not like predetermined. I'm just teleporting to some random place in the world. I'm going to go over here to this kind of plainsy area because it's a little bit nicer to measure in. So let's measure right here. So I'm going to dig a 4-block deep pit. That is the first step to measuring this eye. If you want to do 2 throws. There's a different way to do it with 3 throws, but I want to do it with 2 throws. So throw my eye, let's look at it. FOV 30, measure. Okay, so now we hop in the pit, and we dig 2 blocks away from us, place down a sign. So now we know we are ASCII. We are 2 blocks away. We're looking at the negative first block from the diagonal. We're to the left 1 block. We're looking at the 6th letter. We're looking at the first pixel, and we're all the way through it. Actually, I think we might be looking at the 2nd pixel, and we're like halfway through it. It doesn't really change it all that much. I am just pedantic as fuck. So that is our initial measurement. So now we need to, in order to do axis calculated, we need to turn 45 degrees. So what I'm going to do for that is I'm going to line up on this pixel on the dirt block. This, it doesn't need to be as exact. So I'm just going to say I'm going to be about a 1/4 of the way to the left of this 3rd pixel. So I turn, I go 1, 2, 3, 4, I'm all the way up. What did I say? About a 1/4 from the left of this 3rd pixel. So let's go 1, 2, 3, 4. So I'm going to be measuring from right here. So I want to build another eye measuring setup. I'll show you the second option that you can use, which is you build a setup above ground. You need to go up 4 blocks for a 2-block away measurement, and I'll place a sign here and here. Again, I could be doing this and then control pasting it in, but I don't feel like doing that. That just takes time, so I'm just going to do this. So I will throw my eye from up here, and then I'll hop down here, and I'll measure it. So let's look. Okay. I didn't really get a good measurement there. Okay, that looks good. Okay, so I want to be looking right here. So that is 2 distance, -1 block. We're looking at the 2nd letter. This is a big change. We're on the 3rd pixel, and we're kind of sub the whole block. So I'm predicting a 2.3 degree angle change. That's a big angle change. So I'm thinking we're like 400 blocks away from the stronghold. 400 blocks. Pretty dang good. So our actual calc was 2.3. 2.3 is 398. So we were off by 18 blocks, which is pretty good. Pretty good. So I'm going to do this again. I'm just going to, like, again, type in random coordinates. I feel like that was not the best demonstration because, was this like the same coordinates? I can't remember. I don't think that was the best demonstration because, like, it was so close. So I'm going to teleport to another spot. I don't know. I don't want it to be like too close to where I teleport. This is probably too far out, actually. Whatever. This will be a far measurement. So it's not as accurate when you're measuring far, like most measurements. So again, start by digging down 4. So actually, I'll show you the 3 eye throw method. So your first eye throw, you just get a direction. Your second, I throw. You want to have already built your setup. So I'm just going to build a setup like this. It was looking pretty diagonal, but I couldn't tell if it was to the right of the diagonal or to the left. So I'm going to be throwing from right here. Oops. I didn't get a good measurement. So this is my first measurement. Let's go back. So we're 2 blocks away. It is the negative first block. We're looking at the 5, 10, 15, 16, 17th character. And we're on the 0th pixel. We're all the way through. So again, I'll tell you how exactly I know it's the 0th pixel later. It's basically, if it's lined up on the very left, it's the 0th pixel. It's lined up on the right, it's the 7th pixel. That's just how I decided to count it. You do you. Screw off. That's just how I decided to do it. So that was facing like right here. So now I'll turn 45. It's like, again, it's like a little bit off of this diagonal. It's like a little bit to the left, so like probably right there. 1, 2, 3, 4. So I'm going to be throwing my second eye. I'm just going to call it right here. So you have like two options. You can build another setup, or you can just like kind of waddle your way back to that one. I'm going to just waddle my way back to that setup that I already made, because, I don't know, just because. So that, I haven't touched my mouse. I think this is good. Sorry, I'm not the best at this. I just use bow tie normally. So let's go over to the measurement station. Okay, so we are looking, again, 2 blocks away, negative first block. This time, we're looking at the 5, 10, 15, 16th block instead of 17th. And, or sorry, 16th character instead of 17th. We are looking, sorry, I'm getting real close to my monitor. I think this is the 2nd pixel. And I think we're all the way through, basically. So this is predicting a 0.37, which is 2,400 blocks. So let's see how accurate this is. 2,400 blocks. Now look at that. Look at that. Legit more accurate. Is it more accurate? I don't know. It's so accurate. It's within 20 blocks. Like, at this point, the only difficult part is keeping this angle in the nether. Which is just kind of brain RNG. But I've been brainstorming some ways to do that. I was thinking, oh, if I know that it's X amount of blocks away, I can do the math and reduce my render distance and then take the furthest key point out on the landscape, like, oh, that mountain is loaded at 24 render distance or 17 render distance, so it's this amount of blocks away. That's kind of what I was thinking for navigation, but like that's not really the best in the nether because everything's blocked by terrain. And then you've got, like, obviously you've just got the difficulty of staying on angle. So I think that no F3 axis calculated is looking very, very swanky. I think it's looking very, 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 very promising. One more addendum. When I made this, it kind of looks like a calculator, right? It is technically a calculator. It does one subtraction problem, But well, it also does the sub problem. If you always have it on sub 1, then it only does one subtraction problem. If you have it on 0.5 or something less than 1, its sub is always between 1 and 0, by the way. So if you have it anywhere between 1 and 0, then it's actually doing a little bit of math problem. But really, all this is doing is just going down here and it's saying, oh, I'm looking for the to distance, -1 block, 17th letter, 0th pixel. So to distance, -1 block, 17th letter, 0th pixel. And it's just saying -2.8. That's what I'll return. What sub does is if you make it 0.5, then in order to know that, oh, I'm halfway into this one, it just takes the previous measurement and it adds, or well, subtracts half the distance between them. So the distance between -2.08 and -2.14 is 0.06. So it adds on a 0.03, or it subtracts a 0.03 because that's half of that. So that is that theory. So I think that this wraps up the second proof, the kind of, I would say, what's a good word for it? I would say working prototype of no calculator axis, sorry, no F3 axis travel. Thank you for watching.